All right, ladies and gentlemen, we're going to talk about a skill we're going to need in the future. And this skill is called synthetic division. So we're going to use synthetic division to divide polynomials. Okay? The problem with synthetic division, it only works for special type of problems. It does not work for every type of division problem. Okay? And when we use synthetic division, our problem or our divisor has to be in this format, where you're going to have x plus or minus some type of number. We'll call it a. Okay? So again, synthetic division only works when you have a divisor x plus or minus an a. We can't have x squared. We can't have x to the third. We can't have 2x here. So if you look at our example here, in example A, our divisor is x plus a number. That means we can use synthetic division. If this is anything else like 2x plus 1, can't use it. X squared plus 1, cannot use it. So it only works for these type of divisors. Okay? So let's get started. We're going to do example A, and synthetic division is just a faster way of dividing. Okay? So let's go ahead and we're going to go through these steps here. So just like when we did long division, we want to arrange our terms in standard form, highest degree to lowest. Okay? We cannot skip. All right, so we cannot skip powers. So our powers of our dividend, or the guy being divided, we cannot skip those. So make sure, just as the same rule as long division. So let's do this. So I'm going to go ahead and start in step 2 here. And step 1, these two I'm going to kind of put together. And we're going to draw this box that you see over here on the right. Okay, we're going to set up our problem like that. So the way we're going to do that is I'm going to take each coefficient, as long as I have not skipped a power. I'm going to take each coefficient and write down that. So I'm going to write down 2, positive 6, and negative 8. Notice I am ignoring the variable. I didn't put x squared, I didn't put x, I just put the numbers. Okay? Then we're going to create this box here. And this is all step 2. Okay, so this is my synthetic division box. Notice how it looks like this guy over here. All right, so step 2 is done. What we have to do, to complete step 2, we got to fill in this part right here, which I like to put in a little box. Okay, the number that goes here is actually the constant that you're dividing by. So I'm dividing by x plus 1. I don't care about the x. All I care about is the constant. So I'm going to put this constant positive 1, and it's going to go into this box. Okay? So our divisor's constant goes into the box, but we want to switch the sign. So right now it's positive 1. I'm going to make it negative 1. Okay? So now we are completely done with step 2. So I made a simple mistake earlier. We are actually done with these steps here. Okay, so kind of 1 through 4 we are done with in this diagram here. So basically 1 through 4 is telling you how to set this up. Okay, now we're going to go ahead and focus in on the next step. It says bring down the first coefficient. The first coefficient is this guy, 2. I'm going to bring him down. Okay, I'm going to write him below the line. So he goes below the line. Anything below the line, we multiply with our number in this box. So I'm going to multiply -1 times 2. So -1 times 2. And whatever answer we get, we put under the next coefficient in the next column. So -1 times 2, that actually gives me -2. Okay, so that is that step there. Now we're going to do the last step, which says in our new column we are going to add or subtract depending on sign. So +6, -2, that gives me +4. So we bring this down like this. Do the math in that direction. We get +4. And then we repeat these steps here. So we're going to repeat these steps until we complete the entire box that we have here. So now we're going to go -1 times 4. And the answer goes here. That gives me -4. So what we did was -1 times 4, and the answer went there. Okay. Now let's do this math here. -8 and -4, that's going to give me -12. Since there's nothing else to put in the new column, we have finished synthetic division. What does this all mean? We are going to rewrite our answer. So this guy in the last column, I like to put a box around it. This guy is actually considered my remainder. He's going to be very important later. So -12 is my remainder. How do I write my answer? Very simple. Take a look at your original problem and its power. My original power in my problem was power of 2. What I'm now going to do is rewrite this guy, but instead of a power of 2, I'm going to go 1 less power. So this guy is going to turn into 2x, and 1 less power of 2 is actually power of 1. Again, you don't need to write the 1 there, but I just put it in there so you can see what I'm doing. Okay. Now we're going to bring this guy down. He's +4. And again, think of this as standard form. We have power of 1, and then we put 1 less power here, which is no variable at all. Okay, so this is actually my answer. We bring in the remainder, -12. So that's going to be plus a -12, and we divide it by our divisor. So our divisor was x plus 1. So our divisor is going to go here. And that is our final answer. All right, so example A, we use synthetic division to divide. In example B, what we're going to do is use synthetic division to find a solution. So example B corresponds with this way of using synthetic division. Okay, so again, this is division of synthetic division. Now we're going to see if we can find the solution. So in the part, example B, what it's asking is this. If I plugged in 2 into x, so think of it as a function. So I'm plugging the number 2 into x. So in other words, my problem would look like this. It's asking, what would my answer be if I did all this work? Well, synthetic division actually can help us do this a little bit faster. We don't have to plug in and do all this work. The way we use this with synthetic division is by setting this up exactly how we did before. So the first thing I want to do is take my coefficients. We're going to set this up. I'm going to bring down all my coefficients. But remember, I cannot skip power. So if you look, I have a power of 3, power of 1, and then none. So I'm actually skipping a power of 2. So I'm going to rewrite this guy with this included power. So it should be 3x to the third plus 0x squared minus x plus 6. Okay, but now I'm going to do synthetic division here. So I'm going to create my box. I got my little box over here. Bring down the coefficients just like we did before, so I only care about the front number, so it's going to be 3. Bring down 0. This is negative 1, positive 6. So again, negative 1, positive 6. The number that goes here, when we divided in this problem, it was this number. And we switched the sign. Okay? When it's in this format, we do not switch the sign. We just put whatever number is here, we're going to put it here. So no sign switching here. So that's going to be just straight 2. Okay? And the process stays the same. So we're going to bring this guy down. Any number below the line gets multiplied. So we're going to get 2 times 3. Put our answer here. That's going to give me 6. Do this math. 0 and positive 6, that's 6. 2 times 6. Put our answer here. That gives me positive 12. Do this math. Careful with your signs. That gives me positive 11. And then we go 2 times 11. That gives me 22. Bring this down. And that's going to give me 28. Okay, so again, if we were dividing, this would be our remainder. But since we're trying to find a solution, this is actually what f of 2 equals to. So this is actually now my solution. So I can say f of 2 is equal to 28. Okay, and we don't have to do all the plugging in or anything like that. We use synthetic division to solve. Okay guys, we're going to do a specific problem. We're going to see this in the near future. Just hopefully we can follow along and get this going. So what we're going to do here is we're going to use synthetic division, and our goal is to completely factor this problem. Okay, so we're going to try to factor this problem here. If you notice, just to save you some time, if you actually try to factor this, it's not going to work. So factoring this guy straight up right here does not work. Okay? So we're going to use synthetic division. So we have to understand what this means here. Okay? So it says if I plug in negative 4 into all these x's over here, okay, then my answer should equal to 0. So again, if I take negative 4, just like in the last example, plug x here, 4, negative 4 here, negative 4 here, and do all the math using order of operations, my answer should equal 0. So we're going to see if that's true by using synthetic division. So we're going to set this problem up for synthetic division. So, first things first, we want to make sure that nothing is skipped here. All the powers. So we have power of 4, power of 3, power of 1, and a constant. So the power that's skipped here is x squared. So I'm going to rewrite this really quick. It should be 2x4 plus 8x3 plus 0x squared plus 2x plus 8. Okay, so this is the problem we're going to set up for synthetic division. So let's set up our box. And we're going to take all the constants, just like we did for 2, 8, 0, 2, 8. So 2, 8, 0, 2, 8. Okay, the number that goes here is a number we're plugging in. Again, when you're plugging in a number, do not change the sign. It just goes right here. So that's going to be -4. All right, let's do synthetic division. Bring this down. That's 2. -4 times 2. That's -8. Bring this down. That's 0. -4 times 0 is 0. Bring this down. That gives me 0 again. -4 times 0 is 0. Bring this down. -4 times 0. Sorry, mistake. It should be 2. -4 times 2 is -8. Bring this down, and we get 0. So again, remember this represents my remainder if we're dividing, or it represents my solution if we're plugging in. So if you notice, when it says, when I plug this guy in, I should get 0 as my solution. And as you can see, I did get that. Okay, so how am I going to use this to factor? All right. Okay, so there's an important concept here. Okay, when your remainder or solution is 0, this tells us some special information. That means when you have a remainder of 0 or solution of 0, that you have just divided evenly. And what I mean by that is, because there's no remainder, whatever you plugged in here actually divided our original problem evenly. And when we divide evenly, that has a special name. That's called a factor. So in essence, we have just found a factor, because -4 divided this evenly, we found a factor. And that's what this problem is asking us to do, factor completely. So I'm going to turn whatever I plugged into, I'm turning this into a factor. So to turn this into a factor, you simply put it in parentheses. And what I mean by that is, we're going to put the variable we're using, in this case we're using x, and the guy I plugged in that allowed me to get a 0 solution, we're going to put him in parentheses, but we're going to switch his sign. So instead of -4, he turns into +4. Okay? He is now a factor. This guy, we now know, can divide evenly because he gave us a 0. And that's the definition of factor. It divides evenly. Okay? And anytime you have a 0 remainder, that means you divided evenly. Now we're going to rewrite our problem here. So this answer here, we're going to turn into another factor. So we're going to take this, and just like we did before, this guy, we go and rewrite him with 1 less power. So our original power was 4. This guy's going to be rewritten as, instead of 2x4, he's going to be rewritten as 2x 3. Okay, because he was originally 4, but we divided an x, or we're dividing, so we always go 1 less power. This guy here, we would write as positive 0x second, which is going down the line in power. So we have 3, 2. The next guy would be 0x for 1. And then this guy would be my constant, so plus 2. Okay? So in other words, my original problem has now turned into this multiplication problem. And remember, when we factor, that's what we're trying to do, turn our original answer back into multiplication. Okay, so I'm going to clean this up a little because we really don't need the zeros here. They were just placeholders, but when you have a 0, we can kind of rewrite them without it. So my problem now looks like this: x plus 4 and 2x to the third plus 2. Okay, so now this is my new problem. So we can't factor this anymore, it's done. But if you look at this, can I factor this? And the answer is yes, we can factor using GCF. So I'm going to factor that guy with GCF. So let's do GCF here. And my GCF here is 2. So now I'm going to divide away my GCF. And that's going to give me 2 on the outside, x to the third plus 1. Okay, just to be nice, I'm going to put this guy, he's still part of my answer, so this x plus 4, I'm not going to put him in front because the 2 took his spot. I'm just going to place him back here as multiplication. So x plus 4. Now we GCF'd. We already know we can't factor this guy. We already saw that. But if you look, we have another factoring method here. And what you should notice is this factoring method is SOAP. Okay, so let's continue this problem over here. And we're going to do SOAP. So we have 2 x3 plus 1 times x plus 4, and we are going to SOAP this guy. Okay, so let's SOAP this guy. To SOAP him, we go x times x times x. This is 1 times 1 times 1, and then we put them into SOAP. So I'm going to bring this 2 down. Just put it over here for now, because I can't forget them. And then I'm going to SOAP this guy. So we know it's first with last. So it's going to be x1. And then SOAP, we put our sign here, which is going to be positive 1. And then we're going to go first guy squared, which is actually just x squared. Then O stands for opposite sign, so that's now minus. And now we go first times last goes here, so first times last, that's going to just be x. And then we're going to go last squared, and it's always positive. So 1 squared is 1. Okay, so that's SOAP, and then we're going to bring down x plus 4. Okay, so my final factored form is 2 x plus 1 x squared minus x plus 1 times x plus 4. And this would be your final answer.